Deep in the swamps of New Zealand, a giant slumbered. It was not a dragon or a monster, but a tree. This was a kauri tree, a species known for its immense size and longevity. This particular tree, however, was no longer alive. It had been fossilized, its remains preserved in time. But this wasn't any ordinary fossil. This tree held a secret, a record of a dramatic event that happened long ago. Scientists studying the tree discovered that it lived about 42,000 years ago. This was a crucial time in Earth's history. The tree's rings held evidence of a major change in the Earth's magnetic field. This change was so significant that it flipped the magnetic poles of our planet. Imagine for a moment our planet without its protective magnetic field. This field acts as a shield, deflecting harmful radiation from the sun. Without it, life on Earth would be exposed to dangerous levels of radiation. The fossilized kauri tree, a silent witness to the past, provided scientists with a valuable clue to understand this dramatic event. It is a reminder that our planet is a dynamic and ever-changing place. The Earth's magnetic field is not static. It fluctuates, weakens, and strengthens over time. Sometimes these fluctuations are so dramatic that the magnetic poles flip. This means that north becomes south, and south becomes north. This process is known as a geomagnetic reversal. The Lachon excursion was one such reversal. It occurred around 42,000 years ago, and it lasted for about 800 years. During this time, the Earth's magnetic field weakened significantly. This weakening had profound effects on our planet and its inhabitants. The magnetic field acts as a shield, protecting us from harmful radiation from the sun and space. When the field weakens, this shield becomes less effective. As a result, more radiation reaches the Earth's surface. The Lachon excursion, recorded in the rings of the ancient kauri tree, tells a tale of a time when our planet's protective shield faltered. It is a stark reminder of the power of these invisible forces that shape our world. The Lachon's excursion coincided with a period of extreme environmental change on Earth. This period, known as the Adams event, was a time of great upheaval. The weakened magnetic field led to increased radiation levels, causing widespread changes in the atmosphere. One of the most dramatic effects was the depletion of the ozone layer. The ozone layer protects us from harmful ultraviolet radiation from the sun. With the ozone layer weakened, more UV radiation reached the Earth's surface. This would have had serious consequences for life on Earth, as UV radiation can damage DNA and cause mutations. The Adams event was not just a time of increased radiation, it was also a time of spectacular auroras. Auroras, also known as the northern and southern lights, are caused by charged particles from the sun interacting with the Earth's atmosphere. During the Adams event, these auroras would have been much more frequent and intense, lighting up the sky with vibrant colors. The Adams event, a time of both beauty and danger, is a stark reminder of the interconnectedness of Earth's systems and the profound impact that changes in the magnetic field can have on our planet. Section 4: Extinction and the Adams event, a possible connection. The Adams event coincided with a period of significant extinctions on Earth. Around this time, many large mammals, known as megafauna, disappeared from the fossil record. Some scientists believe that there is a link between these extinctions and the environmental changes caused by the weakened magnetic field. The increased radiation levels and climate change during the Adams event would have put immense pressure on animal populations. These stresses may have contributed to the decline and eventual extinction of many species. One particularly intriguing theory suggests that the Adams event may have played a role in the demise of Neanderthals. Neanderthals were our close relatives who lived in Europe and Asia. They disappeared around the same time as the Adams event. While the exact cause of their extinction is still debated, some scientists speculate that the environmental changes during this period may have contributed to their demise. The link between the Adams event and extinctions is still a matter of scientific debate. However, it highlights the potential impact that changes in Earth's magnetic field can have on life itself. Section 5. A modern reversal. Could it happen again? The Earth's magnetic field is constantly changing. In recent centuries, scientists have observed a weakening of the magnetic field and a movement of the magnetic North Pole. These observations have led to speculation that another geomagnetic reversal may be in our future. If a reversal were to occur today, it would have significant consequences for our technologically dependent society. The weakened magnetic field would leave us more vulnerable to solar storms and cosmic radiation. This could disrupt power grids, satellite communications, and other critical infrastructure. However, it is important to note that geomagnetic reversals are natural events that have happened many times throughout Earth's history. We don't know exactly when or how quickly a reversal might happen, and more research is needed to understand the potential impacts fully. The possibility of a future geomagnetic reversal serves as a reminder of the powerful forces at play in our universe and the importance of understanding and adapting to our planet's ever-changing environment.